Test your biostatistics knowledge. A researcher wishes to test for independence between severe adverse events from a drug, SAE, yes, no, and age, categorized into 3 categories. She observes a chi-square score of 5.2. At the 5% significance level, the appropriate decision, A, could be a type 1 error. B, is a type 1 error. C, could be a type 2 error. D, is a type 2 error. And D, none of the above. The first step in making the appropriate decision is to calculate the degrees of freedom. Now, there's a formula for DF, which symbolizes the degrees of freedom. It's the number of row categories minus 1 times the number of column categories minus 1. Now, it doesn't matter which one of these variables you call the rows and which one of these variables you call the columns, because multiplication, of course, is commutative. So, severe adverse events has 2 categories, yes, no. And age, categorized into 3 categories, has 3 categories. So this is going to be 2 minus 1 times 3 minus 1, which is 1 times 2. So under the null hypothesis, we have 2 degrees of freedom. Now, the next thing we need to do is find the critical value of the test. And since alpha is equal to 5%, we get the critical value by looking up the 95th percentile, because 100 minus 5 is 95, of the chi-square distribution with 2 degrees of freedom. Here's the 2. So here is a screenshot of the table from the back of the book. DF stands for degrees of freedom, and we look for 2 degrees of freedom under the null hypothesis, and the 95 is the 95th percentile. So 2 degrees of freedom, 95th percentile is 5.9915. Now, we have a rule. If the chi-square that's observed, now this is not a letter X, this is the Greek letter chi, it's not chi, it's not chai, it's chi. If the chi-square that we observed is greater than or equal to the critical value, which is the 95th percentile in this case, then we reject the null hypothesis. Now, we got a chi-square score of 5.2 from the problem, and we have a critical value of 5.9915 from the table. And we see that 5.2 is not greater than or equal to the critical value of 5.9915. Therefore, the appropriate decision is to fail to reject the null hypothesis. When we fail to reject the null hypothesis, a type 2 error is possible, but not guaranteed. Think about taking a statistics course, paying for it, studying for it, only to have an error that is guaranteed. That would be anathema to any kind of reasonableness in the world. So, A type 2 error is possible when we fail to reject the null hypothesis, but not guaranteed. And so that makes the correct choice C. Now, of course, if you're taking a Stats 1 class at the college level or a Biostats course at the college level or higher, you need to memorize that a type 2 error is the event of failing to reject the null hypothesis when the alternative hypothesis is true. And of course, you also need to know that a type 1 error is the event of rejecting the null when the null hypothesis is true. And with that, this is Dr. J. Lee Noose for Biostats, summed up.